My submission for the final project video. I have my program right here. Actually, I don't have it right here because I forgot to pull it up. Sorry. This is my third time making this video because I keep losing my place when I'm going over the program. So forgive me. My program was a blackjack simulation that has a Monte Carlo simulation inside of it that gives you like the odds of busting or winning against the dealer and so on. I have two. This one was like the messy one where I was commenting all over and stuff. And using I used inline testing for this because it's since it's random, it's kind of difficult to do unit testing. But yeah, like, right here for instance, if I was testing, I just set what cards I had and then like commented this out and just let it run. So that's how that worked for the testing part of things. Uh, this is gonna be a long video because it's a long program, so I'm just gonna run it to show you that it works first. So welcome to Python Blackjack. If you want, you can view instructions for the game, or you can like read the description about what it really is. But here is the game itself. You start with $100, I bet whatever. I got I got good cards. You can see that it's very likely I'm gonna bust because I have 20, and it's kind of likely that I'm gonna win the stand. I'm playing against a queen, so bush tie. Then you can keep playing. I have no chance of busting here, and so runs again. Every time you hit and get a card without busting, it'll run the simulation. All right, 15 kind of sucky cards, but yeah, all right, that's good enough. I mean, if I'm playing to win, that's what I'll do. But I'll start playing like slowly, so I can kind of like show the possibilities. First thing is disallowed inputs don't work. If I bet too much or something that's not a number, or even like it'll just keep prompting me to do it. So and again, disallowed inputs. I don't know. Let's try to bust here. Oh, okay. Well, now we'll try to bust. Yeah, so if I bust, it just kicks me right out. Dealer wins right away. Let's do what happens when I bet too much money. Dealer got blackjack. Then if you want to, you can play again. I'm going to do a couple more turns because I want to get an ace. Yeah, see, if you get an ace, things get complicated because you have two numbers running. You can see when I go over the program, aces turned out to be like really, really difficult. I had them set up as tuples in some places, and in other places I just like went directly to the totals. Like I was keeping track of 4 and 14, and then as the program goes, I see if this one gets bigger than 21, you just revert to this one. So let's close out here. If you lose, oh okay. If you lose, you can say no, and I'll end the simulation. That's how that works. So that's a program. And here's the code. So, like I was trying to say earlier, this is a really, really, really long program. Looking back, I could have definitely streamlined some things. Considering it's a game, though, I talked to my my lab professor, and he said like for Python games are going to be rather long. So, there's doc strings and things getting printed that are kind of long. So maybe it's not too bad, but definitely hindsight's 2020 with this project. I could have done a lot of things differently and more efficiently. We didn't talk about Big O until after I got started on this, so there's a lot of conditional comparisons. If this was a big program, I'd probably run slow, but fortunately, it's kind of simple. I'll go over a couple of these functions. Populate deck does like a 2D thing. You can see I have the lists up here, and for every suit, it takes all of these and appends it to a deck. Deal takes a card from the deck and then removes it from the deck, so you don't get the same card twice. Deal cards gives the dealer 2 cards and the player 2 cards, and also returns the deck, so you can hit from the same deck without drawing the same cards. This deface card function is kind of not implemented everywhere it should be. I didn't make it till late, and once I made it, there was already a couple places where I did something else. But if the card that you pass into it is in face cards up here, Jack, Queen, King, it turns it into a 10, and that way you can just work with it. Because you can't, do anything with a string J, but if it's a 10, you can add it. Simulate 2 is called Simulate 2 because I originally had a Simulate 1 that was a lot more complicated and kind of stupid. So this is like the Monte Carlo thing that gives you those odds that we're running in function a minute ago. So to kind of break it down, it's complicated, so it's going to take me a minute. Sim equals true. This is for something later. If sim is true and you're hitting cards, it won't print anything, whereas sim is false, it'll print like, oh, you got this. Because, if it's printing, then this might run like 1,000 times, and you don't want that. All right, so if you have a tuple as one of your cards, or as your total, it means that you have an ace. So we want to set ace to true just to keep track of that. If the dealer doesn't have an ace, deface his card and set his total equal to the card that he's showing. If he does have an ace, we're just gonna say it's 11. All right, this is the simulation for standing. So we initialize the dealer's total. That way we don't have to lose track of things. Every time we do the simulation, we make a copy of the deck because it's a list. Then the dealer starts hitting cards until he reaches 17 or he busts. And then at the end, we check, all right, did he bust, or is my total greater than his total? If so, then we add 1, and then we divide by the number of sims. And then you get the simulated odds of winning a stand. Simulation for bust is relatively similar. If anything, it's easier. You just keep hitting. If you go over 20, or you hit once, and if you go over 21, add 1, divide by this, the number of sims. Then you get the odds for busting on hit. And then if you have an ace, you just say, oh, you can't bust with it, because if you have an ace, you have no chance of busting. At the very least, you have a 10. So, all right, hit card. This is the one that hits a card. For the player, if it just takes a random card, and then it says you drew this, takes that out of the deck using the deal function. And then if you have an ace, this is where things get wacky. This is where we return this big tuple, and then ace hit, which is a boolean at the end of it. That way you can refer to it later on from the hit function to be like, all right, did I get an ace, yes or no? Dealer hit is for the dealer. I could have combined these functions maybe, but they just print different things, and this one is a little bit more streamlined and efficient, so there you go. Player turn is the first real big function. This is like printing a bunch of things, doing a while loop for hitting, things like that. So I'll try to run through it fast because this video is getting long. We set our cards, print what you got, check if you had blackjack, check if the dealer has blackjack. We have all these totals get initialized. We use these. If you have an ace, we're going to have 1 total for adding 1 total for adding 11. Then for all the cards that aren't aces, we add them to our total. Otherwise, that means you have an ace. We check which one is an ace, and then we start with adding 1 or 11, and then you have either 2 or 12. Sorry, I had to fix that. I forgot about it. All right, then we do our simulation. If ace is true, we pass in these 2 totals. And then that's why there's an is instance tuple in the simulation function, because then if this is a tuple, it means you have aces. Otherwise, you just do simulation. Then this is to check and see that, that shouldn't be there either. We need to check and see for allowed inputs. Every time there's like a player input, I use while loops. I know you can do those with try and accepts, but it's a little bit more difficult. So I have a try and accept later on, but I like while loops. Then this is the the big thing, whereas while you're hitting cards, you didn't hit 21 and you haven't busted, we start hitting, we turn sim off because we want to print what cards you have. We get you a hit card and we check if it's an ace. That's what this is doing. That's like the last thing. If you drew an ace and you have aces, this runs, which is why it's kind of complicated. If you drew an ace and you don't have an ace, this is when this happens again. Again, pretty complicated because we're going to have 2 totals. Otherwise, you know, you didn't draw an ace and you don't have aces. All right, if you didn't draw an ace and you do have an ace, this runs, which is, you know, you add the new card to each of these, and then if one of them, if the higher number is greater than 21, that means you revert down to the lower number. You can see it down here. So like, say I have, you know, 4 and 14, and I draw a 10, that means I have 14. So now you now have, you know, 14. Otherwise, you get 21. Otherwise, if the lower card goes over 21, then you bust. So that's how the aces are, you know, a pain in the neck. If you don't have an ace, then you just add the card to your total, then you bust, or you get 21. Then at the end, you know, if you didn't bust and 21 is false, if ace is true, this is where you do your another simulation and prompt to hit again and, you know, run it back. So now we're done with all the simulation stuff, or the hitting and the player inputs. So then we just set your total to the higher one, you know, if you have that ace thing going on. If you got 21, then you return 21, and then we move on. If you busted, you return -1 because, you know, who cares? Otherwise, we return what you got, and then we move on to comparing with the dealer, which is the next step in a blackjack game. This one's also kind of a complicated function, but, you know, you take the total that you got from this nonsense up here. You take the dealer cards, both the one that you were shown and the one that you weren't shown, and the current deck. Where am I? The dealer shows his other card. We deface them to turn them into 10s. If he has aces, we do all that, you know, annoying stuff. This is about where I figured out how to do aces right, where it's like if you're below 10, that means we take the 11. Otherwise, you take the 1. Uh, yeah, this is just more checking for aces over here. Then we print what the dealer has, his total. We add up his cards. Then we set sim to false because we want to print what the dealer gets when he hits it. And as long as he's below 17, because dealer stands in 17, he does his dealer hit, gets a new card and adds it. Then if he gets over 21, he busts. And if you are below the dealer total after he gets up to or past 17, you lose. If you're over and you're under 21, you win. Otherwise, it means you're tied, so you push. Now play, this is where we're starting to actually get into some clean functions, which makes me really happy. You do player turn, that big function above, and then you compare with dealer down here. So it's like you do player function. If you get blackjack, bang, you win. If you get -1, that means you busted. So then we just say dealer would have played as follow and just let him do whatever. But we return lose because we don't want the player to have any chance of winning if he busted. If the dealer blackjack happens, also instant lose. Otherwise, yeah, we take the outcome from player tuple, and then we compare it with dealer right here. Yeah, right. We take the player tuple stuff and compare it with that's what happens. And then this plays the full game. It just gives you your money, and then as long as you're above 0, it keeps going. Then at the end, you ran out of money, and you return end. And the main function, this is all like the little cute stuff I had in the beginning, and then play full game equals end, meaning you ran out of money, and then you get your play again, yes or no. And then thanks for playing. So that's that. I went a little bit over the time limit. It took me 12 minutes. I was gonna try to do this in 10, but that's blackjack for you. Really complicated program, actually. I had a lot of fun with it, I can't lie. I just like coding without any direction, I guess. That's kind of why this turned out really messy. But yeah, very fun time. I would do this again, honestly.